Hello everyone. In this video you are going to see what is the circuit used as a differential amplifier, and here we are considering a type of a transistor as bipolar junction transistor, that is a BJT. Since we know that the differential amplifier is the main block used in operational amplifier in order to obtain an application or in order to design an application. Now we will see what is the circuit used here. Okay. The basic circuit used here in the differential amplifier with the type of transistor BJT as one biased circuit. Here we are considering one BJT transistor. To this, the collector terminal, one is a resistor and it is biased with the voltage VCC, and to the emitter terminal again we are using a resistor RE, that is biased with the voltage minus VEE. So it is nothing but the circuit we are considering as an emitter biased circuit. Now with the use of this circuit, with this analog signal, okay, so with this analog signal we are considering it as a weak signal. Why? Because the differential amplifier, what it has to do, it has to perform the amplification of your incoming signal. So we are considering a weak signal, and this signal is passed through this network. Okay, so at this point we have to observe what happens or how the signal will appear at the collector terminal. At this point how the signal will appear, and similarly at this point how the signal is appear at the emitter terminal. Means with the input base signal we have to observe the responses both at the collector terminal and at the emitter terminal. Okay, now we are going to see the function, that is what happens when the signal is appear or applied at the base terminal and how the signal is observed at the collector terminal. So if you observe that from the basic characteristics of a transistor, that is if the input is applied at base terminal and the output is taken from the collector terminal, we can call it as one common emitter amplifier. So we know that from the basic definition of common emitter amplifier, the output signal is the amplified version of input signal, but with introducing a phase shift of 180 degrees. Okay, so this is our input signal. So this is our input signal, that is weak signal, and we are obtaining the output or we are observing the output at the collector terminal. Since this circuit we can call it as a common emitter amplifier circuit. So for the common emitter amplifier circuit, from the basic definition or from the analysis we can know that it will provide an amplification at the output definitely, but with 180 degrees phase shift between the output and the input. So if you observe, the input is of positive half at this portion, the input is positive half cycle, but at the output if you observe, the input is negative. So this is positive and it is negative, so definitely it is providing 180 degrees phase shift. Okay, so this is the output signal that is observed at the collector terminal. Now see how the signal response will be appear at the emitter terminal. Okay, so if you observe at the emitter terminal, we are obtaining the output and the input is applied at base. So we can call this circuit as common collector amplifier or emitter follower circuit. So we know that from the emitter follower circuit, the output signal is the replica of input. Means the same signal is passed through the emitter side without changing in signal characteristics. Okay, so the same signal will appear at the output of an emitter. So which means that at the final stage we can conclude that at the collector terminal, means if you consider the output at the collector terminal, we are obtaining the amplification of the input, and similarly if you observe the output at emitter terminal, it is nothing but the replica of the input signal that is present at the base terminal. Why we have to consider this point, means why we have to observe the waveforms at the collector and at the emitter terminal? Why? Because while doing the analysis, means if you are doing an AC analysis or DC analysis, and if you want to observe the signal appearance, then these basics are very helpful in order to properly understand those concepts. Now, the differential amplifier circuit is designed by considering this couple of emitter biased circuits. Okay, so here what we have to do is we have to make certain assumptions that the two transistors Q1 and Q2 have exactly matched characteristics, and the two collector resistors, that is RC1 and RC2, these are two are equal, which is equal to one unknown resistance, that is RC, and here the two emitter resistors are equal, and the magnitudes, means the magnitudes of these supply voltages are equal irrespective of sign. Now with this, the basic differential amplifier can be obtained simply by coupling the emitter terminals. Okay, the basic differential amplifier can be easily obtained by coupling these emitter terminal of these two emitter biased circuits. Okay, so here it is one input V1 and here it is another input V2. Okay, simply by coupling these two emitter biased circuits we can design the differential amplifier circuit. Now how this is the way how the differential amplifier circuit looks like. Okay, so here if we are observing the output at the collector terminal. Okay, so if the output is taken between two collector terminals, if the output is taken between two collector terminals, then it is called as a balanced output or double-ended output or floating output, which means that if the collector output is taken between two collector terminals without any ground, then we can call it as a floating output. Or else when the output is taken between one collector terminal with respect to ground. Okay, so when the output is taken between one collector terminal with respect to ground, then it is called as unbalanced output or single-ended output. So this is the circuit of differential amplifier using BJT, and that is used in operational amplifier. Thank you.